So then the next deep dive is into the software layer, so climbing up in the hierarchy. Thomas was supposed to help me with this part. He didn't in the end because also he couldn't make it here. He's focusing on his talk for this afternoon. So first of all, what is the software layer? But I hope that's sort of clear by now, but just to make sure it's clear for everyone. This is where we install the scientific software installation, so where we want to get different versions, where performance matters, where we get lots of stuff, where we want to easily add stuff, and easily ingest that into our CVMFS repository. Currently, we're building that all with EasyBuild. That's on purpose because we actually had to implement a couple of new features in EasyBuild to be able to make the connection to the compatibility layer and make sure we're independent of the host OS. I'm not sure if other tools like SPAC, I don't think SPAC supports it currently. There's been some talk on doing something similar in SPAC as well, but I don't think the necessary features are there. You could definitely implement them if you want to. Or other tools. So like I said yesterday, eventually we're definitely open to using other stuff as well. We don't see EasyBuild as a unique thing of doing. Next to the software installations themselves, EasyBuild also generates the module files, so it's very easy to get access to all those installations, even though there's many of them and it's a bit of a mess. And the module files also open up the door to have custom views on the software installation. So without having to reinstall the software, you can have a different organized module tree. So in Compute Canada, they have this hierarchical module tree. We could do the same thing on the side. We could have community views on the software stack, so only bioinformatics or things like this, only for certain projects, for training sessions, whatever. And that's very easy to do. Okay. In the software layer, we have different substacks essentially. So if you've navigated the tree, you should see and hopefully also feel it's nicely organized. So it's clear what's what. Just by the name of the subdirectories, that's of course very intentional. I think we reorganized that a bit since the first time we did it, and now I think we have a pretty good structure there that works well. The modules tool lmod we include in the compatibility layer, so you don't actually need to have that on your system. You can use your own lmod rather than the one from the one we provide, and it should still work fine. So there's nothing really special in our module files that is specific to a very recent version of lmod, at least not today, and I don't see that happening soon. As has been discussed already, ArchPack is currently used to determine the most suitable subdirectory. It does auto detection, that's very good. It has a mechanism also to figure out what's the next best match if there's no exact match. That's an important thing that's maybe not that easy to replicate in Hash. Yeah? Okay. That's very useful because you always get something that works. If it doesn't know about your CPU at all, it will know it's an x86 CPU and it will just use the generic subtree if it doesn't know what the possible best match is. So you always get something that works. That's very good. Our init scripts, which are in our GitHub repository, you can figure out there what we do. So the init script you source is the bash script, which somewhere calls a Python script, which uses ArchPack and then does some additional stuff to that. And that's a part that's definitely up for discussion currently. Now, a big part of the software layer is how we build stuff for it, how we make it bigger, make it grow. So up until now, it's a relatively small set of stuff, applications. OpenFOAM, TensorFlow, you've seen them pass by. We can definitely do a lot more, but we want to prevent doing that effort manually, building that manually, creating tarballs manually, and then having to talk to Bob to ingest that on Stratum 0. We want to automate that whole workflow as much as possible and basically cut out the human as much as makes sense, not fully, because we still want to be able to do this in a secure way while opening it up to strangers and letting them propose additions to the software. We want to do this in a controlled way and make sure we don't get into any nasty surprises there. The way we're doing that currently is we have a big ugly bash script which calls EasyBuild a dozen times, 20 times. We're also pulling in stuff from open pull requests while doing that, because some things, the way we build CMake standard and EasyBuild, We need to make some changes there to actually make it work well and on top of the compatibility layer. So CMake does hard-coded stuff like you look in user lib on your OS, then you're picking up stuff from the host OS, which you don't want to do. You need to tell it to go to the compat layer. So we've have these things figured out already, but they're not merged yet in EasyBuild, and that's probably an effort that we need to merge print to make sure that it's just included in the standard EasyBuild. Then this script could already be cleaned up quite a bit. This grew over time. We're not happy with it, but we do have a better idea of how to do that. I'll come back to that. So this script is basically run for each of the different target CPUs, Haswell, Skylake, x86 generic, different AMDs, different ARM CPUs, currently also still power. So we just run it like a dozen times currently. The way we run it is through our Singularity build container. It's the same one that we use for the compatibility layer, so a controlled environment. I think Bob already explained that well. It's a pretty minimal container, and it's our way of making sure we don't pick up anything from the host. I think our build container currently is actually Debian one, and that's a good thing because that's very different from the OS we usually test in. So we build our software in a Debian container, and then we run tests in RHEL 8, for example, with our software layer, and if it's not horribly broken, we basically know nothing was picked up from the OS. And that's something we can do to the extreme. So have one OS in the build container and then test in multiple other operating systems, also through containers, and that way we make sure we're not picking something up from the OS. Our build container includes CVMFS, so we can mount the easy repository. It also includes Fuse overlay FS, so we can have a writable overlay on top of the read-only mount of CVMFS. And this is how we can just do an installation on top of CVMFS, which is usually read-only. We have some scripts as well that then create a tarball from everything that was added. The tarball, the script detects what was added in the overlay. It grabs all those directories, packs them in the tarball, and we then send that to the Stratum 0 where it's actually in. The build node, it's defined as a Docker file, so it's actually used to live in Docker Hub, now it's living in the GitHub container registry, and we consume it usually through Singularity because use and all this magic. Not that easy to do through Docker. The very good thing, and that's very deliberate, is this setup allows us to, any host where Singularity is installed can become a build host for each. You don't need admin rights or anything special. So a regular user, as long as Singularity is installed in the OS, can become a build host for easy, and that's very good. So cloud, HPC clusters, anything we can start using. If we want to add another type of CPU, as soon as we have, or someone has access to a machine that has that type of CPU, we can start building software for that as well. We've already done a whole bunch of scripting around this. So not only the big ugly script, that's the part we want to get rid of. We also have a script to start the build container. We have a script to install the software layer and do that on top of the compatibility layer. So it's like a cascade of scripts that call each other. And I'll do a quick demo of that as well. And the tarball thing already. Is there a question already? Yeah, wait, Mike first.
Filing on a physical machine with a CPU of the type you.
No, we do VMs as well in the cloud.
Yeah.
It doesn't have to be a physical machine.
It has to have the CPU type.
Yeah,
like,
what we're not doing is cross-compiling.
Yeah.
Yeah, and that's deliberate because we know that's hard.
Yeah.
And also we know that way you can test while you're doing the build. You're on a Haswell system you're building for Skylake, that works, you can cross-compile. You can never run those binaries on that. That's very annoying.
Okay.
Back supports cross-compilation quite well. We've never really looked into that because we know we're going to get in trouble with. So that's sort of a requirement. We need access to build host. Usually that's not a big issue. Certainly with cloud, it's very easy to turn it to the most common stuff. And if somebody has a very exotic type of CPU that they want to get supported in easy, they can. If they run our bot, eventually that will build software on that type of CPU as well, and that way we can still.
You know, by dealing with the problem of chicken and egg scenario with might be nice to have the software available before the CPU. Wondering if that might be a strategy cross compilation.
Well, before the CPU exists, it's going to be difficult. We're not ruling out cross compilation. We can still do that as well eventually. But usually with these, especially in the cloud, when there's new CPUs, there's like some kind of preview phase where some people can get early access. As long as we're in there, we can rebuild, and before it becomes generally available, the software will be there.
Emulate.
Emulating with RISC-V, and the work we've done with RISC-V currently is a lot through emulation, because getting hardware is difficult still. That's changing. But yeah, also the PowerPC stuff we do all through emulation. I don't think we have access to an actual physical power system currently. There's still some around, and if we talk to the right people, we can get access, but it's dead end, I think. So there's other options: cross compilation, emulation. Okay. I'll do the demo at the end. Let me first show you what we actually want to work towards in terms of building software to be included in our software layer. We envision a mechanism where we want to open this up to the community. Even people we don't know, absolute strangers, can send us a pull request with the proposal to add software version, new software, whatever, and get it added into EESSI. Now, what we don't want people to do for multiple reasons is give us a tarball with binaries and say, please push this. That's a very bad idea for multiple reasons. Security is a big one, but also because we want the same software stack across all the types of CPUs, and we cannot expect that everyone has access to all those CPUs. That just doesn't work for multiple. So that's why we'll have these build nodes. So a contributor sends us a pull request in some shape or form. That's not entirely clear yet. We're thinking about, in the scope of EESSI build, EESSI stack files, and I'll explain in a bit what that means. We also think this should be under human review first, so some EESSI maintainer or somebody who's active in the community. This could be a whole bunch of people. In EESSI build currently, we have 23 maintainers who are able to look at pull requests, and hopefully this will become something similar in EESSI. So a human probably should look at it first and just says, okay, this doesn't look like absolute bullshit. Let's go. Then our bot will start actually building the software. So working through the whole installation process and getting the binaries and getting the actual installation directory. And not once, but on every type of CPU. That's going to be dozens of builds eventually, perhaps. So we won't have a single build node, but multiple ones. Thomas is going to explain a bit more about the bot. We've done quite a bit of work on this already, especially Thomas has done quite a bit of work on this already. We're close to something that we think actually good enough to start opening, getting pull requests. Yes.
Yeah, one question here. Looking at the sort of like enormous file you just mentioned with all the installation script, including the pointers to all the PRs to making it sure it works on the Gen 2 environment.
Yeah.
How realistic is that can all be done by bot, or how many human interaction do you expect there to be to make it work? I mean, it works on the EESSI build in a physical system, sort of like end-to-end, that works fine, but including it working correctly on the compatibility layer.
Well, all the bot will do is run scripts.
Exactly.
The bot can be dumb as a doornail.
So how advanced do you need to contributor to make sure that what they are submitting is actually compatible with the EESSI context, and not just the happy scenario of which they expect for their software?
So if they use EESSI build, they in most cases they won't have to do anything special. They'll just have to come up with an EESSI config file, or maybe just add one to the list of EESSI config files, something that's already supported in EESSI. Say, I want this as well. And today, in maybe 90% of the cases, they won't have to do anything special. We have to get that 90% up a bit, but we can fix that in EESSI build. Like the CMake thing is one example. So thanks to the features and the changes we've made in EESSI build, it should be quite easy. If we open it up to other stuff, and let's say to the extreme that people just give us a bash script and to install software like this, that's worth considering. But making sure that's being done on the compat layer and not picking up anything from the host is going to be more tricky there. So in some sense, it's going to be easier because it's just a bash script. You don't have to know EESSI build, but it's going to be more difficult because you need to make sure it doesn't pick up anything that And we have checks for this as well. So we can actually tell if a binary is picking up something from the host, just run LDD on it, and if it's picking up user lib something, yeah, it's hard broken. And we can check this in.
Yeah, Compute Canada have scripts for this as well,
Yeah.
right? So they have a scanner that goes through it, the directory of an installation.
You don't have to be able to run the binary to know something's wrong. There's things you can check statically. So yeah, we're very aware of that, and that's also one of the reasons I think we don't want to force easy build, at least not in the long term, because we want to open it up to a random bioinformatician who wants to add his tool. And if we say the requirement is that it's supported in easy build first, maybe that's too big of a hurdle. And yeah, it has pros and cons, and
it does provide a sanity check, because in the end, what is going to happen is that if anything is broken in the software, people are going to come to you first.
Yeah, I mean, in short term, that's probably what we're going to do. We're going to say, like, it needs to be supported in easy build because for now we don't have time for something else. But in the longer term, that's worth reconsidering, or just see how much need there is to support something else. If there's no demand, or if nobody comes and complains, I have to do the easy build dance first. That's very annoying. Then we'll probably just, or we could, if there's manpower and funding, we could do it as a service as well, where we say, okay, you want this, just you open the request in easy as an issue. I want this and this version, and I don't care about the compiler. Just give me anything. Then maybe very easy for us to support. Now, don't want to do free labor kind of situations there, but yeah, so that's a bit of a.
Yeah, but it's interesting to think about that kind of level of support, because that is something you can seek funding for, right? So there's some things like EOSC, where if you offer a service like that, then there are funding avenues potentially.
Yeah, so this cannot be done by volunteers, and that's something we're a bit careful with in the easy build community as well. Sometimes we see emails passing by on the mailing list, has someone support for this? I almost never reply to that unless I have it ready and baked and I know it's there. But yeah, if you start jumping on these requests, then you also show people that, okay, I just ask and they. That's yeah. Okay. So the bot will essentially fire up build nodes. What we're doing currently is just submitting Slurm jobs, job scripts, which use our build container and use our scripts, whatever they may do, to add that additional software, make it ready for easy to be ingested. In the end, we get a bunch of tarballs. And this part is actually already implemented. We push the tarballs into an S3 bucket. For this, you need a token, so it's a protected bucket. But if the bot can do that, then that's fine. So we're not giving anyone direct access to upload stuff in there. And whenever something is, that's already the case currently, when something is uploaded to that S3 bucket, on the Stratum 0 side, so the central server in our CVMFS network, where you can actually add stuff to the repository, there we have, I think it's a cron job that checks that bucket every now and then. If it sees there's something new, it says, okay, I have a new tarball to ingest. I'll go ahead and ingest that. But there's another check there where the Stratum 0 opens a pull request to what we call a staging repository. That's a private GitHub repository, and that's again to have a human intervention step. And a human has to merge that pull request first before it's actually ingested in Stratum 0. So I'm not sure if we want to keep that up long term. We're getting 100 pull requests a week. That's fun to deal with, and you'll probably just go blind and click merge all the time, and then it's utterly useless. But yeah, we'll see. So maybe if we have a bot, that's maybe an unnecessary step, and we can skip that. So that's the staging repository. A human approves it, and then, well, a bot, it's actually just a cron job. It's not this bot. Goes ahead and actually does the ingestion. Yeah, then you have it in the easy repo, and you're sort of done. Yes, Bob.
Maybe we could change that procedure to just add it to our testing repository or development repository without any approval, and then someone still needs to approve it in order to also merge it into the production one. It's similar to what Compute Canada also did.
Yeah, so basically having an extra step, so it goes to a test repo first, where it goes through CI again, maybe in multiple operating systems to make sure that aspect works. So, but that dance of doing rigorous testing between build and deploy as well, that's something we maybe shouldn't focus on yet. Get this whole cycle working first, and then see how. Yeah.
Is the aim to make that immediately available or in next release?
That's a good question. So that's a currently, as it is now, if it's here, if it's being ingested here, it's there in the repository immediately. What Bob is proposing to have a pre-deploy phase, and maybe we want to only actually add stuff into the EESSI repository once a day or something. Push out all the updates that have been done in the last 24 hours. Maybe more infrequent than that, I'm not sure how tight we want to make that cycle, but yeah, that's open for discussion as well. There's pros in not doing it all the time, probably. Now, we do see, if you look at the CVMFS workshop, the discussions people have there, this publishing cycle is very rapid for them. They do thousands of publications per day, and it's not a big problem to have that and to have the certain ones catching up all the time. That's maybe something we shouldn't be concerned about. I'm not sure if an HPC center will be happy that there's new stuff rolling in all the time and popping up, and users suddenly see, oh, a new version of this, a new version of that. Maybe you want to do that in a controlled way. But I think HPC centers can already do that by themselves. They can stick to a certain revision of the EESSI repository by themselves and only update that at certain points. So in some sense, that's entirely up to them, whatever we do. And maybe that's better than forcing a daily update on everyone or limiting people to a daily update. And we just do the rolling thing, and if they want to do it something different, they can take matters into it. But that's open for discussion. Unclear. I think that's also something we have to explore. Like, are we going to get 2 pull requests a day, or are we going to get 100 pull requests? Eventually, maybe it will be a lot before the whole thing is populated a bit, and then it may taper down. Maybe I've been expecting this for EasyBuild to taper down for a while now, but it's actually ramping up, and we're getting over 2,500 pull requests a year, which is a lot. Will we also get this here? So yeah, this is the end goal. Part of that's already implemented. This part is doing quite well. This part is doing quite well. The bot is under development. To be able to do this pull request in an easy way, so not a pull request into our ugly bash script, but then in a cleaner way, more user-friendly way. Here there needs to be some development in EasyBuild, which is already going on. So Caspar has spent quite a bit of time on that. So yeah, let's say in this corner we're on the way. Here there's a bit of work as well. It's not perfect yet, but we see the view where we want this to be. Yeah, so that's the EasyBuild part. We want to replace this ugly bash script by easy stack files. If you're familiar with EasyBuild terminology a bit, an easy stack file is just like a list of software to install. Just like names, versions, without much details. And then for each of those entries, a corresponding easyconfig file has to be available that tells EasyBuild all the details of what should be installed and how. So this basically, it's probably going to be a set of easy stack files. Different versions of Easy will have separate easy stack files. Probably separate easy stack files for ARM and Power and RISC-V and x86, because not everything is everywhere. Yeah, that's not entirely clear yet. We need those features in first before we can make.
So if we go with easy stack files and we allow people to make PRs, PR is a line in that easy stack file, right?
Yes.
So we're going to have lots of conflicts because everyone's going to be editing the same line. PRs.
Well, it depends on how the easy stack file is organized. We can probably avoid that. So we'll have to be smart about that to make sure. Conflict. We could, yeah. I'm not sure how that. Now if we just do something like, say, alphabetically order them, because the order in the easy stack file doesn't matter. EasyBuild figures out the correct order. That's maybe already enough to avoid lots of conflict. We'll see. It also depends how many pull. And resolving those conflicts is going to be trivial, though.
Yeah, but when people make a pull request and
it's blocked by a conflict, I mean, the easy maintainers could take it over and just push in an extra conflict that resolves the conflict.
Seems funky.
Yeah. maybe we can come up with something better. I'm not sure. Yeah, maybe is some kind of.
I was saying,
yeah, a
just
GitHub action
talk about
that,
a GitHub action that handles that.
that resorts it and takes the latest develop and just injects the new entries in the right place, like this. I mean, it's simple enough. If you just keep it alphabetically organized, it's always clear what has to go where. So you can maybe even automatically resolve the merge conflict. Could be possible. Git is going to be very careful. Going to say I don't know what to do, but we actually perfectly know what the result has to be.
Now, actually, conflicts will only happen if the PR is not based.
Yeah, or if the pull request is open and something else gets merged while this one is open, then it could have a conflict as well.
We are not quick enough to merge that.
Yeah, but well, not quick enough. There may be reasons why it's not getting merged, right? If you're testing on 10 different CPU types and it fails on 2, that PR is not going to get merged unless you make an exception and you say not on power or. We'll have to see how that goes. But I think maybe be able to auto resolve those. Have a good structure. We'll see. Maybe breaking things down a bit more fine-grained, like we have in easy configs. One easy stack file per software letter, first letter. I don't know. Okay, so yeah, pull requests, which is something we're very familiar with in EasyBuild. I got a question on this at the CERN VM workshop. So you have this idea of this automated, or you want to open it up to the community and pull requests, and you may be getting lots of them. I said, yeah, we're getting 2,500 in EasyBuild. Not scared about this. So we know what we're getting ourselves into. And we also know that as much automation as possible helps a lot with being able to keep up. Yeah, and then we'll have the bots running. Probably not a single bot. Maybe we'll have like one main bot that fires up other bots or talks to other bots to get them to build stuff and then come back with a tarball, something like this. So we're never going to have all our CPU types in one place supported. We may have to have a bot in Azure, a bot in AWS, a main bot somewhere, a bot on funky hardware somewhere else. That's going to work. For now, what we're currently focusing on, and Thomas is going to explain that in detail, is a bot that just submits Slurm jobs. So it assumes that it's running in one place, and it has access to a bunch of CPU types. It submits a build job per CPU type. And we could just have the same bot running in 2 places at once. They don't have to talk to each other, just are responsible for different CPU types. We have examples of that. It sort of works out in the end. Not perfect, but
always hinge Slurm cluster, stretch it over multiple clouds.
yeah, there's options there as well. Well, we don't want to lock ourselves to Slurm. So something we're very careful with is locking ourselves in any shape or form. The first version of our bot is just going to be dumb as a doornail and submit Slurm jobs. Not going to be much more than that. But we also want to be able to build stuff in an isolated server where there's no Slurm. We don't want to make Slurm a requirement for the bot. Like if exotic hardware somewhere and somebody has a server and says, okay, there's a new Ampere CPU coming up and I can give you access to an instance that does that, you don't want to install and configure Slurm first before it can run. So just a build node by itself should work as well. Yeah. I think if we get the Slurm thing working first, then we can focus on the other modes. It's going to give us quite a bit of. Thomas is going to talk about the bot a bit more. I don't want to steal his thunder. But before I go to demo, there's a bunch of open questions in the software layer. We're going to open this up to the community and accept proposals for adding software. What are the requirements to actually accept that proposal? Have to be supported in EasyBuild already, so that means there have to be an easy config file for it already. And do we say we don't want easy config files ourselves? It has to be upstream or no, at least for now on the short term. Do we want to accept pull requests that add a line in the easy stack file and the easy config file that comes along with it? so before it's upstream in easy build. Then we have to manage those as well, probably clean them up if they do end up in easy build. So that may result in a bit of duplicate work. How strict do we want to be on tests? So we want to be able to test the software that we have in the software layer. If we do a glibc update like Bob talked about, we want to make sure it doesn't have impact, doesn't break stuff. So we need tests. Are we going to make tests a hard requirement for anything that's added in the software? Maybe. But what do you do with the pure library? You want tests for the library? To something that links to that library and then does something useful with the library? Do you want to go that far? Is this a yes, we want to test, but if there's no test, we'll merge it anyway? Yeah, that's not clear how strict. And maybe in the beginning we should be quite strict there and say, look, there has to be a test or we don't merge it. And then we just see how well that's received by the community and how much of a blocker that is in some cases, and gradually relax that constraint and try to come up with something. I think we want as much test as possible, but also defining the tests has to be feasible. Like if the first step there is take a 2-day course on how to use reframe, then we're not going to get a lot of tests. Yeah, so that's not clear. That's something we'll have to learn over time as we work with the community. Which set of CPUs do we want to support for the next pilot or beta version of Easy? Maybe we want to go a step beyond pilot since we're slowly ramping up to production. Do we want to make that minimal initially? Probably x86, AMD, and Intel. Yeah, we'll have to do those. ARM, yeah, don't have really bad experiences with ARM. That should be relatively easy. Powered, we're going to kick out. I think that's clear now. RISC-V, if we have time, we'll play with that, but we're definitely not going to require that the builds work on RISC-V because that's going to block us in 100,000 ways. So how broad do we want to make this? Unclear.
Regarding, I've just been looking at CPU, and for Intel with the Skylake, we're like at least 2 generations behind. We have Ice Lake, Cannon Lake.
We, you mean Azure?
No.
You mean the targets we have? Yeah.
I think from a Xeon point of view, so going for the large HPC systems, it's valid enough to say, yep, Skylake is relevant. Maybe probably Sapphire Rapids is going to have a bigger impact from performance point of view.
Yeah.
And the ones in between,
yeah, just fall back to Skylake.
We don't know yet. But from a laptop point of view, I mean, if your target is also being able to run scientific software on laptops, desktops, whatever, it is opening of worms. Yeah. So and then your CPU types will pretty much explode. Yeah. So I think have to be precise on why certain are.
And it also has to make sense to rebuild your stuff, right? Exactly. If there's no performance gain in rebuilding for a laptop CPU that supports AVX2, and if you use the Haswell binaries, it works fine. In terms of performance, then why do
on the AVX2 we're probably fine. There are at least sort of like 6 or 7 512 with extension there.
Yeah.
And that is where the real.
Yeah, we'll have to figure out how. And once we have the bot and it works well, adding another CPU type is basically going to boil down to having a system where we can turn into a build node. Because if you're building on a Skylake and building on a Cascade Lake, I don't think I've ever seen a problem where it works on Skylake and not on Cascade Lake. That's true for Haswell Skylake. That's a different story. That gap is bigger. So it should be a lot easier to add in. Now, of course, you're also, the more build nodes you have, the worse, because if one of the build nodes goes down, what does that mean? It'll block everything. You just skip that part and then catch up later. So it's also complicated. Yeah, and that's definitely how we'll need to start. Yeah. Start with what makes sense, which is probably what we have now, except for power. That's probably good enough. And the difference is quite small, I think. Probably small.
The actual-
And maybe just as small for Skylake, Cascade Lake, because there are extra instructions there, but are those actually being used? And if they're being used, how much of the runtime does it affect? You'll probably find something you can cook up a demo that shows, oh, there's a big difference, but in practice, how much does it actually matter?
So maybe we want to actually.
Certainly initially there's a and like with the bot, if we have the bot with the Slurm cluster and it has 4 CPU types and it works well there, yeah, let's aim for that first and then throw it open. Another discussion point is the module naming scheme. So right now it's the default flat. There's a.
Thank you. Just for your information, I've building with Spec a bit older version, but and we do have Cascade Lake. I think Cascade Lake refreshes in our Delft Blue system, but the Spec, let's say, architecture scanner basically picks Skylake and adds AVX 512 and builds with that processor. So I think that we're good in stating that we should
having
not.
one AVX 512 target is probably enough.
That should be fine. Yeah.
And in Ghent we
Some of the newer AVX 512 features are, from a math perspective, potentially really relevant. And they're probably hidden away because most of those software is actually using the dynamic libraries of Intel. So they're using the autopath there. But if we're doing something with GCC or something like that, I think we should really validate before making those assumptions that 512 is 512.
And the tests we have will help there as well. As soon as we have more tests,
the performance
we'll come at a point where, okay, now we actually can do a performance study and see what the impact is of rebuilding.
But then there are 5 dimensions. I mean,
So just to wrap it up, because we're another question, sure.
You started the discussion based on the laptops that right. I don't think we have to optimize laptops. It's just be able to prepare.
What's there in laptops is coming in. So.
The reason for mentioning is that if we have the assumption that we want to support every CPU type, and we're adding this to the game, then it's going to explode. So then we make the problem that we want to solve too big. That is why I brought that up. Not per se as having the opinion that we should support all those individual CPUs.
But there's a difference between supporting and squeezing every last bit of performance out of it. If we have AVX 512 as a target, Skylake one, and Archspec falls back to that, it's going to work. But
best performance.
But there's a middle ground there,
sure.
In terms of effort that we have to spend. At least initially, there's a middle ground.
Yeah, we have to be concise of what and why, and communicate on that, and like make it
just
clear.
have it clear. We're supporting this for this reason, and if you want more builds, help us out or something. Sponsor us.
Also, we could, in that sense, review the presentation of those arcs. So instead of calling it Skylake, we could call it AVX 512, 0, something like that.
There's actually something like this in Archspec already. There's an x86 64 version 1, 2, 3, and 4, which are like SSE, AVX, AVX2, and AVX.
So make collections of instructions instead of
so more like
CPU
a generic
target,
but not generic in the sense that of our generic, but something that anything that supports AVX 512 will support that. So let's say the common part of AVX 512, because there's all kinds of extensions to that, would be supported there, and
And linking with our previous discussion, actually, moving or limiting the amount of CPU architectures that we support also helps in replacing ARCs archspec with something else. Because if we know that we are only have 6 variants, it's much easier to write a script that
Detects
one
those. Yeah, yeah.
before falling back to generic.
Mhm.
So that also helps. And I'm changing. I'll make a question, but in another direction. I'm in favor of having an automated the cycle that you showed before, to having as much automation there as possible. However, do we have any mechanism from the perspective of the system administrators to actually disable modules that might cause trouble in my system? Like, let's say something comes in and in my system breaks for the user.
Well, we'll have a way of creating custom views on the module tree, so you can hide the module, but the installation is still going to be there. So
Yeah,
hiding that,
But
like,
that's my point. No,
like
so, I mean,
masking it.
I don't mind if the installation is there. The question is, to have a mechanism to avoid the users coding those modules that I know for some reason might be broken.
The module files we have, you can copy that tree and throw stuff out,
Okay.
and just create your custom view of that tree.
Yeah,
Where the
that's-
module files are located
yeah,
doesn't matter,
Okay, yeah, I know.
and it's
but,
tricky dependencies, and yeah, it's,
I mean, but copying the module tree, it's kind of a lot of it's work. I mean,
we could support something like this, like
Well, I mean, it's not that much work because you just take the easy stack file. In the end, you just take the easy stack file and remove the ones you don't want, and just rebuild. Just do a module only on that.
Yeah.
On that easy stack file, and that's it.
you don't even need. You don't even.
Oh yeah.
But you don't even
for
need
that
to
I
do.
need easy build. So that's the point.
You don't need to do module only at all.
Something that can be done with just L.
Oh yeah, well yeah, and Lmod can hide stuff. Yeah,
but
sure.
I need write access module tree.
No, you need to give Lmod a different configuration.
From the configuration side. Okay, yeah. I was okay. Yeah.
Or a hook, yeah, but Lmod supports like just a flat list of modules. Don't show those in
Okay.
in module
So-
FAL.
We probably should have.
Yeah.
Because.
Sure.
Prep is gonna.
I've been thinking about this for related to the module stuff in general, right? About hiding stuff and making it easier to do that. And that's why I think this thing that I've been talking about for the last week or so about the idea of categories, doing better on categorizing software in general, but still having everything visible in the module tree. But like saying, like the only categories I'm interested in are bioinformatics, right? So show me bioinformatics, and when I load a module, it'll still load all the dependencies, but I won't see them when I'm looking at my tree, right? Show me these default categories, and that's it. Everything else is there, and it avoids this issue of having to give me a custom view. I have to go right now I would have to rebuild my own module tree. But if I had something like categories or some mechanism like that I could hook into, then I can avoid all this. And also, it's a way. I like the idea of categories, of actually collaborating with people on how to categorize software, because that's hard, right? And it's changing.
How to define the view? I mean, that's something we don't spend a lot of attention to. But
now,
if people run module VAL in our system, they go insane.
But now we can control that right now, because now we know we have this tool where
we can
provide
talk to the
view,
community
right?
and say, help us out here. What kind of view do we need to? Yeah. Okay. Yeah, and then so the module naming scheme, the hierarchical thing is another. So we can have multiple views and allow you to create custom views, and that's definitely.
But I think for me, just the easiest thing is to go with the two of those. We ship the two of them.
Yeah.
And then if we have this capability on what is actually
Creating
displayed
custom
based
views,
on something, right?
Yeah.
And we can change that later, right? Because that's just an Lmod hook or a plugin or something.
That's easy.
right?
Providing another module tree is very lightweight. You don't have to rebuild anything at all. Yeah.
There will be administrators that will want, for instance, in the naming scheme, that they will want hierarchical or flat.
Or I mean, you could have an option to the init script, right? That says, Joe, give me this view of easy. Yeah. Okay. The discussion with the compat layer, that I think Bart and Bob already covered that one. I do have a quick demo, and I do want to show this because maybe people want to play with this during the hackathon. So what I have here is I have is big enough? Be a bit bigger. So I have the software layer repository checked out. This is our collection of scripts. So these call each other, so it's a bit of a mess, and we should have a good overview. But there's basically two entry points. There's the build container script, which helps you to fire up the build container. This one, Debian 10, right? Has some options for that. It creates some temporary directories, magic like this. So that's an important one. And then this one, install software layer, is, you guessed it, it installs the software layer, but it does it by calling other scripts. So in this case, we're doing the .12 version, the latest pilot version of EESSI. It runs a script run in compatibility layer environment. So it basically runs this script in the Gen2 prefix in the compatibility layer environment. So you don't have to figure out how to do that. It does it for you. And what we really end up doing with the build container is going to tell me how it works. I run something, you need to give it a path to a temporary location. That's where it uses the directories it will bind mount for CVMFS and all that magic. And then I think I have to do it like this, install software. So this is basically how we currently build things. So we use the build container script to fire up the build container. We use the install software layer script, which pushes us into the compat layer, and then it runs that installation script. And now it's going to run through everything. Everything is already there. So all of this is going to be green. EESSI build is going to see this module is there, so I'm done. This module is there, so I'm done. And it just runs through them one by one. So this is what we've cooked up, which is what we're not happy with this, but it does work. And it's pulling in stuff from GitHub, from PR, and EESSI blocks also from PR. So this works well. Yeah, so if you want to play with that, that's basically what you need to look at. And currently, if people want to add new software to EESSI, they basically add a block into the EESSI pilot install software script. So a couple of commands in there that tell you which EESSI config file to install and whether robot should be enabled or not, whether pull request needs to be pulled in or not. That's how it's done, but yeah, that's not something we want to open up to community requests. That doesn't make a lot of sense. That's too involved, but it does work.